Hello and welcome to another lesson on soundproofing. Today we're going to be talking about one of you guys' favorites, baffle boxes. That's right, I'm going to show you my latest design on how I design baffle boxes like the pros with my clients so that you guys, if you're doing this yourself or if you're interested in learning how I work, this is going to be a great lesson for you. Before we jump in, my name is Wilson Harwood. I am a professional studio designer and acoustician based in Nashville, Tennessee. I build soundproof spaces for a living. Now, before we jump into this lesson, I want to let you know that I do have a free resource for you. This is my free soundproofing workshop. It is 30 minutes of in-depth teaching going in 3 different types of builds, both in a garage, a backyard studio, and a basement studio or basement office, where you can learn how I designed these 3 different types of builds so you can know what goes into a project like that. All right, to check that out, just go to soundproofyourstudio.com/workshop and you can sign up and watch it for free right away. All right, enough of me jabbering. Let's dive into this lesson on how to build baffle boxes like the pros. All right, so here is a finished project of one of my clients. We built this in a basement here, and you can see right off the bat we have 2 big old baffle boxes on the outside of the walls. This is actually a great way to do it. As you can tell, baffle boxes are annoying. I laughed with another studio designer over Instagram the other day. I was like, man, baffle boxes are just such a necessary evil. And he was like, tell me about it. And so we all, in the industry, we all joke about these things. But I will tell you, I've talked to professional HVAC technicians, like a mechanical engineer, and he said, a plywood baffle box is still going to be your best way at sound attenuation over fancy plenums, pre-made things. He's like, it's the best. So I can tell you with assertion that this is the best way to design and stop noise from going in and out of your studio through the Duct system. So your question, how do you build these dang things? Well, let's start with the basics. So let's go over a baffle box first, and I'll show you how this works here. So if we go into my HVAC file, we got our baffle boxes. So let's see if I can take this off. It's so nice there. We can just look right in. So a baffle box in essence is a really simple design. You have the air, in this case, the green represents the air from the air handler in his basement coming into the baffle box. It goes around these baffles like this, and then it comes in and it goes through the wall system and into the studio like this. Whoop, whoop. Super fun. Whoop, 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 whoop. So that's how that works. And now I'm going to break down what it is that we use to build this material. So this right here is called duct board, D-U-C-T, duct board, like duct tape. And it is a special type of insulation meant for HVAC systems. It means it will repel moisture. It's been tested for mold growth. It's not your typical insulation, and it's also not going to have a siding on it that makes it so you don't like breathe in the fibers. Now, I use something that's not fiberglass. I use this stuff that's actually based out of cotton, so it's a lot healthier for you. And this is my 2-inch Ecoverb lining. You can buy it from Second Skin. There it is. I'm giving you away all my secrets. Second Skin Audio sells it, and you can use their spray adhesive to adhere it, and you can also use we use screws with like big metal washers to hold it in place as well. So that is the duct liner. Then we use 3/4 inch plywood right here to actually build the box itself. And this plywood is going to be attached directly to our concrete wall using concrete masonry screws, just like, you know, attached directly in here. And then we have 5/8 inch drywall after that. And that is what's going to give this box enough mass and density so that sound from this basement, let's say you were banging on drums in the basement for some reason, we don't want that sound to get into our box and come right into our studio. So these things are super massive. Sometimes I'll add even more layers if I know I'm going to need more sound isolation. So in essence, that is simply what a baffle box is. There's nothing super crazy about it. But you might be wondering a few things like, how do you size the baffle box? How do you decide the distance between the baffles? How do you decide how big the baffles are? How do you decide any of this stuff, Wilson, is probably what you're trying to figure out here. And let me answer those questions for you. So for this design, it's kind of unique. I have two situations where I have baffle boxes. So the 2 situations are If you are going to be using an ERV system, then you're going to have the CFM, meaning the cubic feet per minute of airflow that is going to be coming from your ERV, which ERV stands for Energy Recovery Ventilator. You may be using an HRV, meaning a heat recovery ventilator, if you are in a certain climate like the Southwest where it's dry and hot, or very, very cold. So dry places technically use an HRV, and moist, sort of more humid climates tend to use an ERV. In the United States, ERVs are generally what we're going to use for most climate zones. So let's say you're using that and you have 150 CFM coming into your baffle box. Well, that's fairly easy. Now we know we have 150 CFM, so we're going to design the baffle box for that. In this case, though, what we have here is we actually have the actual air handler for the entire house going into this system. So what I do is I figure out the number of air changes per hour that I need for heating and cooling loads in the room that I'm trying to heat or cool. And for that, we need to go into some special calculators. So here is a calculator I created for my designs. It's called my Ventilation, Heating, and Cooling CFM calculator. And it takes into account some of the air changes per hour for just ventilation. But for this situation, what we're going to do is look down here and we're going to put in the total square footage and the ceiling height of our studio. And that's going to give us the number of the CFM, the cubic feet per minute of air needed for 6 air changes per hour, which is to code for heating and cooling load calculations in our system. So to do that, we're going to go back over here and we're just going to say, okay, what is the square footage of our room? And I can actually do that pretty quickly in SketchUp here, which is nice. I can click on this little tool and I can go boop, and it'll show me 221 square feet is the total square footage of our room, including this little closet area over here. So 221, let's remember that number. And then let's figure out the ceiling height, which is basically going to go up to the top of this, I believe. So about 6 foot, 9 7/8. And we're going to have to turn that into, I think, inches for this to work correctly. All right, so I already forgot this number. We're going to have to go back and forth. 221. So let's go back to this calculator here. And what we're going to do here is the square footage is 221. The ceiling height is going to be in feet. So actually what we can do is just go, it's going to be feet. So our inches are going to have to be a decimal for this to work correctly. So what you can do here is actually what I do a lot is inches to feet. And we can go back over here and say, okay, what was our height here? Blah, blah, blah. 6 feet, 9 7/8. It doesn't need to be super, super accurate. So we can do 6 feet. And then the 9 here, which is going to be 0.75, super easy math. So we'll just do 6.75 in this example here. And that'll give us 149. We'll round it up to 150 CFM to properly heat and cool this room and this will provide ventilation, because what's happening in here is that we're pulling the air handler from the rest of the house. Now, it's not as good as having a dedicated ERV, but in this situation, we're keeping things simple and we're just going to have the air coming through the air handler, which is pulling in air from other parts of the home. So we are getting some sort of air transfer and air exchange and ventilation in and out of this room, which is what is the important part. Now, because this is 150 CFM, what we need to do next is we need to go in and figure out our Ductilator, which is this cool little thing. You can go to Ductilator.com and you can basically just say, okay, we know our max our airflow rate is going to be 150. So that's what we just figured out. We're doing 150 CFM. The maximum air velocity, we always want it to be 300 or less. So 300 feet per minute, or ideally less if we can get away from it. Static pressure I usually leave at 0.08. That's totally fine. I've read that 0.1 max static loss per 100 feet inches per water gauge is actually totally fine for a system. So we're just going to leave that the same for now and not worry about it. Now, what's cool about the Ductilator is you can start to see the size of round duct, the size of a square duct you would need to keep the speed of the air. Now, this is confusing, everybody. We have two things here. We have CFM and FPM. What is the difference? Well, one is the cubic volume moving through at a certain feet per minute, and the other is the speed, meaning just the feet per minute. So we got to go back to our high school physics class and think about these two different things we got going on here. We've got a volume of air moving through, and then we've just got the single point line, the speed of the air going through, and that's our feet per minute. And what we care about is both, but we really care about for the sound of the air. We don't want it to move so fast that we end up hearing the sound coming into our studio. That is a no-no, and that's why we can't have a high rate like 750 or something, where you would, get all of these things in here and it would just be a huge mess. So we can't do that. So we're gonna keep this down to 300 feet per minute or less, like I said. Now, if we go back to the original Baffle box design that I did in the studio, we can calculate the square duct size that I created. So we have 1 foot going this way, and then for the height, we have 1 foot. And this is pretty typical of my Baffle box designs. If I have the space, I'm going to do a 1 foot by 1 foot duct if I can get away with it, or even bigger. Because if we go back to the Ductilator, let's say we did 1 foot by 1 foot. So I'm going to change this to 12. I'm going to change that to 12. We get a nice solid 150 feet per minute. We are half the speed of the maximum air velocity, and everyone's happy. That air is going to slowly just drip into the room and you won't hear it at all. It is a beautiful thing, everybody. Beautiful, beautiful. And so what we want to do here is make sure we over design our Baffle boxes when possible. So the bigger you can make these things, the better, as you can see. So that's how I designed it. Now you might also want to know, doing the math, like you basically have to build backwards. So you're like, okay, my internal duct size is going to be 1 foot by 1 foot. Now for the total size of the box, you need to start with your interior design. And when it's all built like this, you might say, well, that's easy. It's so easy. It's just a box and it has these baffles. Not so fast, Maverick. These things are not so easy to do as you might think. So what I did is I actually created a Baffle box calculator where I can type in my depth, my duct width, and I know you guys are gonna be like, where's the calculator, Wilson? I was like, oh, this is not for free. This is some of my proprietary stuff. My clients can use this. I actually have a group consulting program where my clients can come in and get access to all of this, but not just anybody on the internet. But you guys will know how to do this now, so it'll help. But this is kind of cool. This tells me the thickness that I want for my liner. It'll tell me the depth of my box, the length of my box, the width of my box, and the length of my baffles, so that when I'm building this thing, I can know exactly what size I need to make it based on the size of my duct width and duct height. So it's pretty cool little calculator I created, but you guys can do it on your own. That's why you're DIYing it. If you're doing this, is you just got to learn to do some of the work on your own. So the return Baffle box is exactly the same. It's just in reverse. So we're coming through here, we're going around like this, and it's coming through the air in reverse. Red means stale air in my designs, and this is going to go back to the air handler wherever that may be. And you can see on the inside here, we've got our little supply register right here, and then we've got our return register down low here, and it's going to be great. This client is going to be so happy, and it's going to be comfortable and wonderful and amazing in their podcast studio. That was a quick rundown of how I design Baffle boxes like the pros. This is how the pros do it. So if you guys want to design your own Baffle box, rewatch this, learn from what I told you, use the materials I use. I've done this for a long time. I've gone through many, many different types of the insulation materials and all that stuff. So I hope this has been really helpful. Comment down below if you have questions. There's definitely people in the community that can help you out. And if you guys are on this journey and you just watched all that and you're like, dang, that's a lot of work, Wilson. I don't know if I want to do all that work. I don't blame you. I wouldn't do it myself either. I do this professionally for a living now, but if I was a producer, a musician, a podcast studio owner, I wanted a quiet office or anything like that, I would not take the time to try to figure this all out on my own. If that is you, I highly recommend you sign up for a Soundproof clarity call so that I can talk to you about how I work as a professional and how I could potentially help you. To do that, just go to soundproofyourstudio.com. You'll see a little link that says, I want to sign up for a Soundproof clarity call, and you can click on that and you can go and sign up right away. 30 minutes with me, No questions asked. I'm just here to help you guys. Now, for those of you who are like, no, I'm not ready for that, Wilson. That's a little too fast. I still want to DIY this. I still want to do this on my own. Or if you're just curious to learn more information, definitely check out that soundproofing workshop. Just go to soundproofyourstudio.com/workshop and you can watch it right away. I'm giving away all the goods. I give everything to you guys. I do not care. I want you to learn. I want you to know and understand. So it's just giving it all away. So if you want to learn that, just go to soundproofyourstudio.com/workshop and I'll be happy to teach you everything I know about how I build home recording studios and soundproof rooms in general. So, all right, everybody, my name is Wilson Harwood. I, again, am a professional studio designer and acoustician based in Nashville, Tennessee. This is what I do for a living, helping people like you build soundproof spaces so you can just have that wonderful quiet space you've always wanted. I'll see you all next week with more information on soundproofing and room acoustics. Until then, keep it real, everybody. I'll see you all later. All right, bye.